We are acutely aware of the sound which results from waves reflecting off surrounding walls or objects. I call this quality the space of the sound. It's also known as reverb. The size of the room, the configuration of the walls, as well as the hardness or softness of the material of the walls affects reverb. I'm in a recording studio now. It's soundproofed and has soft panels and carpeting. Ideally, we would also have no parallel walls or parallel surfaces. This studio has a very dry signal. Now, I'm in a stairwell. There are many hard walls and parallel surfaces. It's a very reverberant space, and we call this wet. In a reverberant space, it's very easy for sound to get muddy, so I have to play more slowly in order to be heard. The most dry sound we can possibly get is in an anechoic chamber. An anechoic chamber, anechoic meaning non-echoing or echo-free, is a room designed to completely absorb reflections or waves, be it sound or electromagnetic. The quietest anechoic chamber in the world has a noise floor of negative 12.4 decibels. Remember, the human ear can typically only detect sounds above 0 dB, so we would perceive the surroundings as devoid of sound. The longest that anyone has ever managed to survive in the anechoic chamber at Orfield Laboratories, which has a noise floor of negative 9 dB, is just 45 minutes. As humans, we are attracted to reverberant spaces, and there are many kinds of effects which simulate the component of sound that results from reflections of surrounding walls or objects. Some people think these are just delays with a little bit of filtering, but it's much more complex than that. Play around with the settings on your reverb and listen to the results. Most beginning students put too much reverb on their tracks, so try to be judicious.